Okay, so you have learned a lot about programming. You've learned a little bit about Python. Let's today talk about moving our theoretical notions about programming into practical Python programming skills. Okay, so you'll see that this is idle. Okay, this is the window you've been working on before. It's Python. The program is called idle, IDLE. That's the integrated development environment that we've been using for Python, where we type our code. What you've done so far is, and this is the default setting for when you first open this program, this is called interactive mode. And so you can type in command by command individual programming commands, okay, like this one, which is going to, when I press enter, the interpreter is going to run, and that line is going to be executed, and the result of that line will be the word hello. Okay, that's the print command. And we can also do, and you've tried stuff like this, so we can do 4 plus 7. Okay, we get 11. We can try 2 star star 10, or asterisk asterisk, or splat splat 10. And what will that do? Well, obviously 1 star will give us multiplication. What will this do? Well, that is how we encode exponentiation. So that's 2 to the power of 10, and that's Python code for that. Now, this is all good and well, and interactive mode is useful, especially for testing quick statements or calculating something very quickly that we want to calculate using our simple programming language. But in order for us to actually write programs, we're going to need to step into what's called script mode. Okay, and script mode is where we get a blank document. We can type in the entire program, save it, come back to it later, modify it, and then when we're ready to run it, the entire program runs, one line at a time from top to bottom. Or in the case where we have branching statements or selection statements, maybe there's the proper looping or proper branching happens. But each construct is taken from first to last, top to bottom, left to right, and it's all run at one time. So in order to do that, we're going to do file, okay, and then we're going to do new file, and a new window opens up. And this window looks kind of similar to the other window over here that we have, but this window, you'll notice, isn't running. We don't have a prompt in this window over here. This is not running an interactive version of Python. Instead, you can think of this as just a blank document, a blank text document. Okay, so let's try this. Let's try print. Okay, and then we'll do hello world. Okay, print hello world. All right, let's save this. Save as. And it, by default, will save it as a .py file, and that's perfectly fine. That is the file extension for Python scripts, which is sort of the name for a Python program, a stored Python program. And I'm going to save this on my desktop. You can save yours wherever you like. So here I'm going to call it test Python. Right? And you can see that it's now called testpython.py. If we shrink these windows, you'll see this is the file on my desktop right here, testpython.py. So we can now do useful things like, all right, close this window. Okay, how about if we double click on this? There it is. Okay, or alternatively, we can do file open and go to the desktop. Okay, test Python. There it is again. Okay, so it's a stored program. It's stored for later use and modification. Okay, how do we run this? Run. Okay, well, there's Python shell over there. That would open the Python shell. But what we want to do is run the module, or F5 for short. Run module. Okay, there it is. There's the output. It says we restarted We ran the program, testpython.py, and the output of that program was hello world. Okay? Now notice that print is a function. Okay, we can tell it's a function because it has parentheses, open and close parentheses, after it. Okay, there are other kinds of functions, and we'll see how to use those as we go along. One thing that's going to be useful and necessary for you is comments. Comments begin with the hashtag. So a Python program that displays a hello world message. Okay? And what that hashtag did was it told the Python interpreter ignore this line, or ignore everything on this line after the hashtag. Okay? So I can do this an inline comment as well. This is a print call. Okay? So let's save this. Let's see if anything changes in our execution. Nope. These comments were entirely ignored. Okay? We can write multi-line comments. This is something that you'll be asked to do. Okay? Written by Daniel Ray. Okay? CS 135, computer skills and problem solving. Okay? One more, date written. Okay, so May 25th, 2020, which is the current date as I record this video. Okay, I'm working a few weeks in advance. All right. Notice there's some distinction here that will be helpful to you as you are doing stored program scripts in Python. Red text always indicates that this is a comment. This sort of purple text, okay, indicates that this is a special word, right? It's a word that means something special to the program. Green text are our strings, okay? A string is a group of characters, okay, that we want to treat as a whole unit, okay? And then you can see the purple text, green text over here, and the output is always in blue text, okay, when we run the program. All right? So, one challenge that I want us to do, the first challenge I want us to do together, write a Python script to print first name, blank line, last name, blank line, and then your academic major. Okay? Give that a whirl. As I'm going over this stuff, you might want to, you will want to have Python up and running so that you can try these out for yourself. Okay. All right. So the first line is, here's what I want to do. I want to do first name. Okay. First name. In my case, Daniel. Okay. How do you think I should print out a blank line? Okay. I'm going to try this to begin with. All right. Print out. All right. Ray. That's my last name. Okay. Print a blank line. Print academic major. Okay. Computer science. Okay. Is that right? I don't know. How am I going to find out if it's right? I am going to test it. Okay. The act of programming is actually the act of debugging. Okay. Simply put, debugging is taking a program that we want to do something and testing to make sure that it actually does those things under the circumstances in which it might do them. Under any circumstance, any possible input, it always gives me the right output. It's not generally possible in in even slightly more complex programs to test all possible inputs. So we tend to test the troublesome inputs or the most likely inputs. And we do a run of tests on our programs that are carefully selected test cases to trying to determine if our program always seems to properly function in those cases. Well, for us right now, this is a very simple program that should just do a static thing over and over again, so there should only be one test. And for the most part, that's true for what we're going to be doing this semester. But if you plan on going forward into computer science or CIS or IT, then a major component of software engineering is the testing. You can think of programming as really being the act of debugging. Okay, they are one and the same. Simply writing the program out the first time, that's easy. Once you know a little bit about the syntax, it's the making sure you did it correctly that is the hard and time-consuming part. So let's test this. We'll run it. Yep, got to save it first. Okay, so that did not work, right? I did not get this. These prints did not give me a blank line. Let's see what happens if I do this. Okay, so let me run it. Run that module again. It'll be asked to save it first. Okay, so, what am I missing? Notice I had an error pop up there. Okay, what if I do that? Okay, save it. Much better. Daniel, blank line. Ray, blank line. Computer science. Okay, now technically what we actually have is Daniel, empty space on this line, Ray, empty space on this line, computer science. Now for our purposes, that's probably fine, but a stickler might say, look, that's actually not a blank line. I don't know if you know that or not, but there's actually a white space, just a space on each of those lines. It looks blank because you can't see it. So what if we did something like this? Okay, let's try this. Let's run that. Okay. All right, so that gives us a new line between the outputs. Okay, and maybe that's technically more correct. Okay, what does this mean? Notice you don't see, even though it's a string, you don't see \n being stored here. Okay, the reason why is because this character is called the escape character, and when you escape in, you get a new line. Okay, and so you might run into that some other places as well. \t, for instance, makes a tab. Okay, let me show you what I mean. Let's try this. Here, I'm going to comment these out because I don't want to see this every time. Okay, and what I've done here is I have taken, yes, even though this is a statement in Python, because I've put the comment symbol, the hashtag, at the front of that line, that means that the interpreter, the Python interpreter, will treat the entire line as a comment and ignore all of that. So everything that's in red text here is getting ignored, right? As is indicated by the red text. All right. So what happens if we do this? My quote is, I love quotes. Okay. All right. How about print cat, comma, dog, comma, mouse? Well, that's a different construction altogether. What's going to happen in there? All right. Well, how about this? Print cat, dog, mouse. Okay. And then sep equals \n. Okay. And notice as I'm typing this little tan box is popping up. this is telling me a lot about the options that are possible in the print function. Okay, I'm not going to go into too much detail about that, but you'll begin to see as you go along that is giving you several options for how to do things. And what I would recommend before you use a function is that you get comfortable looking up what those functions mean and what the options for those functions are using python.org, which has a wealth of resources on all the functions available to you in Python. Okay, so let's see. This is good. This is what 1, 2, 3, 4 print methods. So let's save this, and then let's run the module. Okay, so it says my quote is quotation marks. I love quotes. So if you want to include quotation marks in your string that you want to print out, then you can use the single quote around it, and then you won't have any problems. Okay. What happens if I do this? Notice you have to think that you have to realize that the interpreter is reading this from left to right. And when it comes to a quotation mark, it says, this must be the beginning of a string. And when it finds the next quotation mark, it says, that was the end of the string. Notice how this is in black text and not green. And then it finds a new quotation mark, says, well, this is the beginning of a new string. End, that's the end of the string, so this is the empty string. And what is it going to think about the words I, love, and quotes? It's not going to know what to think if you do it this way. Okay? It has misinterpreted your meaning. So if I run this, it's going to give me the invalid syntax error, and it's going to direct me to where the invalid syntax was. Now, what does this word syntax mean? You may have come across this in your reading. Syntax is simply the correct structure of the language, the expected structure of the language. So when you're programming, it's not possible just to type anything or type something that can be interpreted by humans. It has to be something that can be interpreted by computers. And the one thing we remember about computers is that they are literal to a fault. They do not know anything except what they expect to find, the limited amount of things they expect to find. And that set of things they expect to find in your programming, in the programming language, defined by the programming language, embodied by your code, that's called the syntax. And if you break the syntax, then you get what's called a compile time or a runtime, generally a compile time error, right? As this is trying to figure out what program you have just written and then write and execute that program, interpret that program, it says, I don't know what I is because it's not part of a string, because this is the end of the string right here, and then there's this thing called I. You haven't defined a variable called I, so I don't know what this is, and even if I did, I wouldn't know what love is, and I wouldn't know what quotes is. What you meant to do was this. You meant to have your quotation marks be part of the string literal. And that's easy to do in Python by simply using the single quotation marks instead of the double quotation marks to encompass the quote. Okay? Cat, dog, mouse. By default, we get those all printed out on the same line with spaces in between them. Cat, dog, mouse. What about cat, dog, mouse, and then this setting, sep equals \n. Sep is short for separate. So you've got 3 strings, cat, dog, and mouse, all comma separated. Without any of this, the separation between them is by default a single space. But when you set the separation between them to \n, remember just a moment ago we said \n meant new line. And that's precisely what you're getting. Cat, new line, dog, new line, mouse. And we also said that \t meant tab. Cat, tab, dog, tab, mouse. Okay? Python is meant to be responsive, it's meant to be flexible, it's meant to be easy to use and easy to learn. Okay? So how about print that is end equals space, okay, print all folks. Okay. Now without this, the end of the line is automatically a new line. Okay? By default, that's how it works. But when you set the end attribute in the print method to something besides new line, you don't get a new line between those print methods. So what you get is you get all of this on one line. So it prints out that space is, and then a new line, a space, and then continues printing all space folks. Okay? And then this by default, as with all print statements where you haven't explicitly said otherwise, this ends with a new line so that the next output will be on the next line down. Okay. Like so. All right, so that's another option. Okay, so let's talk about string concatenation when we're doing printing. We can do this. Print Python plus is plus fun. Now it's kind of weird, or it may be, to think about adding strings to one another, but that's precisely what this symbol says we are doing. Okay, that's called the concatenation symbol in this case, because it takes this string and it adds this string, spaces included, to it, and then it adds this string to that. Okay, and so the result is that one string, Python space is space fun, is what gets printed out. Okay, Python space is space fun. That's called string concatenation. There's also some more interesting things we can do. Print, okay, fish times 5. Okay, so let's run this. There it is. Fish, 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 fish. Right? Printed out the word fish 5 times. Okay? Let's use our first variable in this setting anyway. How do we define variables in Python? Well, it's super easy. Okay? It's very easy, especially considering sort of the overhead for other more complicated programming languages. That's why we've chosen Python as sort of the first programming language for most of you. All you do is you use a variable. Okay, you just pick a name. Okay, the name I have picked for this variable is quote, because it's going to store a quote. And then I use the assignment operator. Okay, this is not the equal sign, not in this context anyway. This is the assignment operator. It's going to set whatever is over here on the right-hand side of it to be the value of this variable. Okay, and so I can put in quotation marks any string that I want. Programming is cool. Okay, now whenever we make use of quote, we are going to print, it's going to have the value programming is cool. So if I, for instance, say print quote, okay, all right, so let's run this. It's going to ask us to save it. There it is, programming is cool. Okay, we didn't print out the word quote. Notice this was not in quotation marks. If we had put this in quotation marks, then we would see the word quote printed out. Okay? Because this is no longer a variable, it's a string, right? But this is a variable in this context, and so what the compiler does is it says, well, what is quote? Is this a variable you've defined beforehand? Yes, it is. We found it right here. Here's its value. Okay, so we'll print out this value as the output for this program. Now, we've seen before what happens if we haven't set a variable called quote and we try and print that out. We get an error right over here. It says quote is not defined. Okay, and it'll tell you this is on line 27. So if we go over here and we look down here at line 27, this is line 27 of this document over here, right? And it says quote is not defined. The reason why is because we haven't had a statement yet that defined quote, just use the name and set it equal to something, and that defines it and sets its value. And then you can use it in statements later on. Okay? How about print? Let's do some more things that we can do with string type variables. Quote dot lower. Okay. Print quote dot upper. Okay. Print quote dot title. Print quote dot capitalize. Print quote dot swap case. Okay, and print quote dot replace. Okay, programming tennis. Okay, so let's see what this does when we run this program. Okay, and then I'll talk about exactly why those things, what's happening. Whoops, we forgot something. We forgot to close the outside parentheses. And we left the parentheses off. Okay, there we go. So we see this is the original text. Programming is cool with a capital P and a capital C. When we did dot lower, we got all lower letters, lowercase letters. When we did dot upper, we got all uppercase letters. When we did capitalize, we got the first letter in each word capitalized, uppercase. When we did swap case, okay, we got the cases. Sorry, what did I forget? Oh yeah, so programming is cool. Sorry, we did title, then we did capitalize. Sorry. So title is each of the words is uppercase letter. Capitalize is they're all lowercase letter except for the first letter, and then swap case is they're all from the beginning. Okay, the P was capitalized to begin with. Now it's a lowercase. The C is capitalized to begin with. Now it's the lowercase. Now every other thing which was lowercase before is now uppercase. And then this one is interesting, quote dot replace. We take the word programming and we replace it with the word tennis, and the output is now tennis is cool, not programming is cool anymore. Okay? So you can kind of see by the name used here, lower goes all lowercase, upper goes all uppercase, title makes every word the first letter of every word is uppercase. Capitalizes just the first letter of the string. Swap case swaps the cases of every letter in the string, and then replace helps us to replace a word. All of those, this dot operator, right, works because this is a type of variable called a object, and in fact it's an object that stores a string. And this happens by default. We didn't have to do anything like that. This is just sort of behind the scenes. These objects have methods, functions associated with them, and these are them. And we can tell these are functions again because they have the open parentheses, close parentheses after them. If you leave off that open parentheses, close parentheses, okay, then things don't work. Built-in method, lower of string object, blah, 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 blah. Right? That doesn't work the way we expect. That's actually given me the address of where the method named that is, rather than calling the method. So it's important that we have the parentheses on there. So what gets printed out is the result of calling the lower method associated with quote. Right? So things inside of parentheses happen first, and then the print method happens. Okay, same thing with all of these: upper, title, capitalize, swap case, and replace. Okay, so that's pretty much what we want to do. What we want to know about the print method. So down here, I'm going to do some mathematics. Okay, and while I'm at it, just to keep our output as simple as possible, I'm going to comment out all these print or output statements. Okay. Mathematics. Okay, we already know we can do something like 5 plus 9. Okay, we can do 3 minus 7. We can do 4 times 2. We can do 18 divided by 5. We can do 18 divided by 5. Okay, and we can do 18 mod or percent 5. Okay, so what does this mean? Well, let's run these and let's see what happens. Nothing happens. Okay, why do we have no output here? Okay, let's try it this way. Let's set variables equal to these things, because we need somewhere to capture these results. Okay, and then I'm going to print num1, comma, num2, num3, num4, num5, num6. Now see if you can predict what the output is going to be from printing all of these using the same print statement and having them be comma separated. Okay. All right, so it looks like 5 plus 9 is 14. And it looks like 3 minus 7 is negative 4. So good so far. 4 times 2 is 8. And then 18 divided by 5 is 3.6. And you'll notice that this automatically gives us a non-whole number, right? As we'd expect. Okay, great. So what do you think 18 divided by 5 is? Well, the result is 3. So why do you think that is? Why is that? Okay. Well, what this actually does is it returns the floor of the division. Okay? So it returns only the whole number part of the actual result, which is 3.6. What does this do? Why do we get 3 here as well? Okay? This is the modulus operator. What you heretofore have known as the percent sign is in programming the modulus operator. And what does mod mean? It means find the remainder of dividing 18 divided by 5. Okay? So how many times does 18 go into 5? It goes into 5 3 times. But that is not what is being printed out here. Okay? What we're defining is the remainder. So if 5 goes into 18 3 times, and 5 times 3 is 15, then how short are we from 18? 18 minus 15 is 3. Okay? We're finding the remainder. And that's useful sometimes, right? So for instance, if I want to know how many times, right, if I have 83 cents, how many times can I, how many quarters is available in that? Like how many quarters should I give out if I have 83 cents in change, right? So let me run this. And the answer is, oh, sorry, my math is wrong. My math is obviously wrong. This should be what's left over if I take out some number of 25 cents. Yeah, scratch that. It's not how many quarters are in here. That's what division does, right? 83 divided by 25 tells me how many quarters are in there. 83 mod 25 tells me how much money I still owe after I have taken out the number of quarters that I could take out, which would be 8 cents. So after I take out 3 quarters, I have 8 cents still left over. Okay, sorry about the confusion. I hope that makes sense. All right, so we're covering a lot of ground just in general. So if you do have any questions, there are places on Canvas where you can ask questions. Obviously, you can ask them to me directly, either via email or via Canvas message. Both of the Canvas message goes to my email anyway. Okay. All right. So the next major topic is we've done a lot with printing out information. We've done mathematics. We've used a variable to store a string. We've used variables to store number values. Let's get user input next. Almost all the programs that you're going to write are going to rely on getting input from the user. Okay. Otherwise, or from some other source, right? Input from some source that is outside of the program itself. Otherwise, the program always acts the same, right? Because it has what's hard-coded stuff in it, right? And those are not generally interesting or very useful. Okay, so I'm going to have a variable called name, and I'm going to use the input function. Okay, and then I'm going to put a string inside of the parentheses for the input function. Okay, so let's run this program. I don't actually want that anymore. That's going to cause an error. Let's run this program. Hold on, in order to organize this, let me put this up here. And see what it does. Okay. Notice it says, what is your name? But the program hasn't stopped yet. Okay. I just have, if I go down here, I have a blinking cursor, right? The reason why is because it's waiting for me to put in my name, and then it stops. Okay. So what happened? Well, the value of name is going to be whatever is the result of the input statement. And the input, function really, the input function gets input from the user, from the keyboard. Okay? And it's designed to print out this string right before it takes input from the user. Okay, so it prints out what is your name, and then it waits for the user to type in their name, and then that value is set as the value of this variable. We can prove this, right, by saying print hello, okay, and then we can do name. I want to put a space in here because I want to have a space between name and hello. All right, so let's try it. All right, go down here, I'll type in my name. Hello, Daniel. Okay, in fact, we didn't need this space right here because comma-separated variables or strings that are in the print statement automatically get a space between them. Hello, Robert McRobertson. Okay? So whatever was typed in here got stored in this variable because we used the input function. And then this variable was printed out. Hello, the string hello was printed out, space, and then that string that was stored in name. Okay? So we could do other interesting things with this, right? We can do age equals input, okay? What is your age? And this space right here doesn't matter, but I like to leave it off just because it looks tidier. Age. Okay, so now let's run this program. Okay. First, it's going to ask me for my name. And it's going to say, hello, Dr. Ray. It's going to say, what is your age? Okay. It's going to say your age is whatever you typed in. Okay. And print out whatever you typed in. Now, this is a little bit tricky. Okay. This looks like a number, but in fact, it's not a number. Okay. It is a string. Okay, so what if we want to do this? What if we want to figure out something like, I don't know. Let's do x equals age divided or mod 10. Right? So how many years has it been since your last whole number of 10 birthday? So if you're between 10 and 20, how many years has it been since you were 10? If you're between 20 and 30, how many years has it been since you were 20? If you're between 30 and 40, how many years has it been since you were 30? Okay? And then let's print out that value. Okay, kind of a weird thing to ask or want to know, but maybe we do. More importantly, we want to see what happens here. Okay, so what's your name? What's your age? Okay, boom, something exploded. Okay, let's see if we can understand what this is. This says that the problem is on line 50, and that is line 50. I can tell by looking down here that's line 50. All right, so the problem is right here. And in fact, it's given me the code where the problem is, and it says there's a type error. Not all arguments converted during string formatting. Weird. So you typed in a number, okay? But remember, I told you that by default, things that come in from the input function are treated as a string, right? And so what the compiler doesn't know how to do is to take the string representation of your age, okay, and mod it by 10. It doesn't know how to do that, right? So what we have to do, if we're going to use that your age as an actual numeric value, is that we have to convert the string into the numeric value that we want. And in this case, since it's a whole number, we can do int out in front. Okay? And int is another function that takes in this case, a string, and takes that value and converts it into an integer. Okay? Now, these names may be unfamiliar to you, but int or integer, okay, that simply means a whole number. In float, and I know you've seen some of this in your reading, that means a floating point number or a decimal number, any number that has a whole number part plus a decimal part. Okay? In our case, your age is always going to be entered as a whole number, so we're going to convert it to an int. All right? That means now age is an integer, and then we'll be able to do whatever value you typed in, mod 10, store that value, which will also be an integer, in x, and then print out x. So this should work now. Okay, so what's your name? What's your age? Okay, it's been 9 years since my last whole multiple of 10 years. Okay, so since I was 30, it's been 9 years since that time. Okay, all right. Questions about that? Please reach out and I'll try to answer all the questions that I can. There's one more thing I want to do. Let's do number equals 20 divided by 3. All right, and so let's do print number. Okay, let's see what happens. Oh, I really should get rid of that. In fact, I am going to comment that part out. Comment these lines out so we don't have to see them every time. Okay. Like so. You'll see that 20 divided by 3, when you print it out, it's 6.6666666 repeating. Okay? And much like a calculator, the last thing is rounded off to 7, but it's really 6.6 with the 6 repeating infinitely. Okay? It does not divide into a whole number. So what we get is a floating point number or a float number, right? 20 divided by 3. Oh, incidentally, I should mention that if you're going to be getting a floating point number from the user, you can also do that to convert the input into a floating point number, right? And you'll need to do that if you want to use it in a mathematical formula. Okay, so we get a floating point number and we print it out. How can we format this better? Maybe I only want to see 3 digits of the output, okay? So here's what I do, right? I can do something like this. The number is... Okay, and then a number formatting string. It always looks like this: %.3f end. Okay, percent number. Okay, so this is neither a percent sign nor a modulus sign, and neither is this. This is just a special character usage for what you commonly know as the percent sign. This says, take the number, the thing after the percent sign here, take whatever's after the percent sign here, and only show, use it as a floating point number, and only show 3 decimal points. Okay, so we get 6.6667. We can change this to 2 decimal points. That's 6.67. Okay. All right. Any questions about that? I'm going to pause here. There's going to be another video where we talk about some more stuff. Okay, but I don't want our videos to be too terribly long. So I'm going to pause here, and you can work on this stuff. Let me know if you have any questions about just this fundamental Python stuff. We're going to create sort of our first program when we get back to our next video. So if you're fine, go on ahead and go immediately into the next video. If you have questions, let me know. We are running on a tight schedule this week, so do not hesitate to ask me questions. And furthermore, do not slow down to get to the next video. Go on and get to that as soon as possible, okay? Because that's going to be critical. It's going to have critical information for your labs this week. Okay, hope you're well. You'll be hearing from me soon.